In this video, I'll be discussing organizations and information systems. This comes from Chapter 7 in your textbook, which marks the start of a new overarching topic of how we can use information systems to gain competitive advantage. In particular, today we'll be talking about business functions, functional systems, the role information systems play in business processes, and finally we'll discuss a few information systems that cross functional boundaries. But before we get into that, I'd recommend reading over Chapter 7 in your textbook and trying out some of the MyLab MIS homework for the weeks before watching this video. Remember, these video lectures are meant to be supplemental, and they add to the textbook readings. So for example, I'll add summaries of the textbook content, I'll add examples, clarify concepts, and go into more depth on certain subjects. But these videos are not intended as a replacement for doing the assigned readings. Also, for this lecture in particular, it's important to have read Chapter 3 and watch the Chapter 3 lecture on productivity, innovation, and strategy, as we're going to be building really heavily on some of those concepts, namely competitive advantage and Porter's value chains model. So let's get into it and start by looking at business functions and functional systems. Recall Porter's value chain model from Chapter 3. A value chain is a network of value-creating activities in which each step in the value chain adds some value to the product or service. These value-adding activities can be divided into two categories: primary activities and supporting activities. Primary activities are the core parts of a business which directly add value to a product. They directly relate to an organization's customers and products. These include core functions such as marketing and sales, inbound logistics. Inbound logistics would be the handling of raw materials and supplies coming in and inventorying them. Operations or manufacturing. These would be the activities relating to actually producing or manufacturing your product. Outbound logistics, such as actually shipping your product out to your customers. And services and support. These would be providing customer support for your product after the purchase has been made. Supporting activities are secondary to the main goal of the business and only provide value indirectly. These often are parts of the business you don't think about, but are critical for it to run effectively and efficiently. They facilitate and provide support for primary activities, often by supporting employees, providing infrastructure, or aiding in decision-making. These include procurement and technology. This would include your IT department, for example, accounting and infrastructure, and human resources, or as we sometimes call it, HR. Primary activities tend to have an order they incur in. So this would be as raw materials are coming in to your business, inventoried, then eventually transformed into finished products, and then shipped out to your customers, and then support starts. So we sort of go through marketing and sales, then inbound logistics, then operations for manufacturing, outbound logistics, and then service and support. However, secondary or supporting activities, on the other hand, are involved in all steps of the process. So for example, you need HR involved in all those steps, or you need IT involved in all those steps. So what does this all have to do with business functions? Well, each of these activities, both primary and supporting, are business functions. Business functions are the activities carried out by an enterprise. They're the combination of all primary and supporting activities. These basic functions are present to some degree in almost all businesses across all industries. So it's really important to understand each and its contribution to the business's goals and objectives. All business functions have a cost associated with them, as well as some value they add to the business. The difference between this cost and the value they add is what we call margin. And if we want our business to be successful in the long term, we want this margin to be positive and remain that way. In terms of information systems, each of these business functions or activities can be supported by a functional system. Functional systems are information systems that support the work of a single department or business activity. For example, marketing and sales activities are supported by sales systems. These would handle things like order management, lead tracking, and customer management. Logistical operations and manufacturing activities are supported by operations and manufacturing systems. These would deal with things such as inventory control, customer service, scheduling, and manufacturing operations. Support activities are also included, We have accounting systems to support financial activities such as ledgers, financial reporting, and accounts payable and receivable. And HR also has systems to support human resource activities like payroll, recruiting, and training. The point here is that each activity or function in a business may have a specialized information system targeted specifically at the work done in that department or for that activity. So that sounds all well and good, but it also brings us to a bit of a problem with this approach of having separate, isolated information systems for each business function. Let's take a look at an example to really explore this. Let's say our business uses three main functional systems when processing and completing an order: a sales and marketing system for running our website and taking orders, an operations and manufacturing system for inventory control and to support our manufacturing process, and finally an accounts system for dealing with accounts receivable and payable. All of these systems are isolated from one another and have their own software, hardware, and databases. Employees in each department only use their department's information system, and management has to separately query each of these functional systems if they want to combine any of the data for reports and planning purposes. So I want you to take a few seconds and think about what kind of issues we might encounter in isolated functional systems like these. Recall, each system has its own database, its own software, its own hardware, and there's very little interaction between them. Try thinking about it maybe from the perspective of a manager. So I'm going to give you a few minutes on a timer, think about it a bit, and try to come up with an answer. And we're back. The big problem here is the isolation between the systems. In real life, these business functions are not completely separate. For example, sales influence inventory and management, which in turn influences accounts payable and receivable. If you get a really big purchase order, that means you're going to need the correct inventory of raw materials in stock to actually manufacture the product. And this in turn means that you have to purchase more materials if you're getting low. And that means you're going to have to interact with suppliers, and that's also going to influence accounting and accounts payable when you actually have to pay those suppliers. But in this isolated functional system model, there's no easy way for sales to communicate to operations that a big order is coming in, or for manufacturing to tell accounting that they'll need to buy more supplies to meet this order. Another issue is that management has to manually go to each system to pull data to create any kind of report or do any kind of data analysis. We call this type of isolation functional silos. These are systems that are designed to work independently of one another and don't consider other organizational areas. This is a problem as each silo has its own view of the data, its own processes, and its own procedures, even has its own goals and objectives, and their own business model. This allows business processes to become disjointed or even ineffective. In simple terms, the left hand doesn't know what the right hand's doing. Every department is blind to everything but their own data. Now you might be wondering why we can't simply just send the data between these systems. Well, unfortunately, it may not always be that easy. Recall that each of these functional systems has its own database and its own software. That means the data in one system may not be in the same format as required by another system. Let's take a look at a little example to explore this. So let's say we just got an order, and it was processed by our sales and marketing system. The order data has a product code and a price for each item in the order. So far, so good. But the problem starts coming in when we now look at how our operations and manufacturing system is storing the same data about our products. Each functional system has its own copy of the data, and its own database, and its own software, so each may handle it differently. In this case, the operational inventory system might use a different style of product code without a dash or without a leading zero. It may also store the price as an integer, that is, a number with no decimal places. These differences would make it hard to share data between these systems unless someone was manually sitting there and correcting each order that came through. But wait, it gets a little bit worse. Our accounting system has to handle the accounts receivable procedures for this order, and it has its own database and its own copy of this data. And if we have multiple copies of the same data, we may start getting inconsistencies, or as we like to call them, data integrity issues. In this case, the product code and the prices in the database are inconsistent with the sales system, as there's no communication between these systems to keep everything in sync. This could obviously cause some major problems. Think of if the price is different in accounting than in ordering, the customer might be charged the wrong amount. Another issue is that maintaining each of these functional systems costs money, and we're duplicating a lot of our efforts here. Each system has its own database, its own hardware, and its own software. These are all largely redundant, as some of these services could be offered from the same hardware, the same server, or use the same data store. Since they're not, that means we have to spend money maintaining each and worrying about things like upgrades and maintenance on all of them. So what's the solution? Well, fortunately, due in part to all of these issues we mentioned, most businesses are moving away from this functional model of information systems and starting to add or move to cross-departmental systems. Cross-departmental systems, as the name would suggest, integrate data and business procedures across different departmental and system boundaries. They enable data transfer and communication between different business functions and allow for unified business processes and models to be used across a whole organization. These systems are also called cross-functional systems. Most businesses today employ a mixture of functional and cross-functional systems. When cross-functional systems cross organizational boundaries, we call these inter-organizational systems. An example might be sharing an information system with a supplier that manages raw material orders, such that materials are automatically ordered and arrived just as you need them in the manufacturing process. So now let's take a little bit of a break from talking about functional systems in Chapter 7 and practice some access input masks. Now I know access input masks are a little bit of a departure from the subject we're talking about in this video, but they're an important skill to have, and I want to dedicate a little extra time to working with them. So you may have already completed your access assignment, but it is good to take another look at these because they are a good skill to have, as I mentioned, and they are going to show up again on a quiz and the final exam. So earlier in this lecture, we saw some product codes or IDs. What I'd like us to do is try to come up with access input masks that match each one of these codes. We can assume that the red characters are uppercase letters, the blue are any lowercase letter, the green are numerical digits, the numbers 0 to 9, and the black are literal characters, in this case just the dash character. Also note that the number of digits in each product ID is a bit different. So I'm going to put up a timer now, and I want you to try to think back to our access tutorials and come up with an input mask for each of these product IDs that we saw earlier. Pause the video if you need to, and refer back to those access tutorial slides if you need reference for what each of those input mask codes do. And unpause the video once you think you have an answer. You can even test it out in Access if you'd like. And we're back. Let's take a look at the solutions. For the first product ID, we have 3 uppercase letters, followed by a dash, and then 4 digits. The first thing we need to do is handle the capitalization. We do that with a greater than sign, which tells Access that all the following letters must be uppercase. Next, we need to handle the 3 letters. The character L in an input mask denotes that a single letter must be provided. In this case, we have 3 L's, as we need 3 letters. Next, we need to handle the literal dash character. This is always a dash in these codes. To denote a literal character, we can either surround it by quotes in the input mask like this, or we can escape it with a backslash like slow. Both are equivalent, but the quotes are easier to use when you have multiple literal characters to match that are all in a row. Lastly, we need to deal with the numbers. In this case, we want there to always be 4 digits exactly after this dash. So what we can use are the 0 characters in the input mask, which state that we must match at least 1 digit for each 0. As we want to match 4 digits, we add 4 zeros. If we wanted to make the digits optional, we could use the 9 character. If we wanted to state that only the last digit must be provided, we could use a mix like this. This would allow us to input 1 to 4 digits. Looking at the second product ID, and following this exact same set of steps, we'd get an input mask that looks like this. Again, the greater sign is used to enforce capitalization. But this time we only want 3 digits, so we just have 3 zeros. Let's look now at that last product ID. And since we're following simpler steps and dealing with a similar product code, we're going to get a similar input mask. So the big difference here is that we're using that less than symbol, as we want the letters in this input mask to be lowercase. And now we have 5 zeros, because we want 5 digits. An important thing to note here is that the 3 L's in the input masks are still capitalized. Recall that an uppercase L in an input mask means that you must provide a letter, while a lowercase l is not a valid input mask character. The capitalization in the input mask has nothing to do with the capitalization of the text that it's being applied to. Only the greater than and less than signs control capitalization. And this brings us to our participation activity for the week. This week, I'd like us to get a little bit more practice with access input masks and formatting codes by trying the input mask practice quiz on OWL. As this is a participation activity, the grade you get on this quiz doesn't matter, just that you put an honest effort into completing it. The goal here is that you're practicing your input masks, so it doesn't really matter how you take the quiz. So there's no real rules for this quiz. You can take it as many times as you like. And it's not part of your quiz grade, so please don't stress too much about it, and take your time and use it as a useful studying aid. Okay, so back to Chapter 7. We'll now be moving on to the topic of integrating functional systems. Recall from earlier in the lecture that simply copying data from one functional system to another will not work. As we saw, you might get issues with different data formats, incompatible software, and even data integrity issues where the data is not consistent between each database. So how do we cross the bridge between functional systems and integrate them into a proper cross-departmental system? Well, this can be a very complex task, and it's a difficult transition to make. However, there are 2 standard approaches. The first is Enterprise Application Integration, or EAI for short. In this approach, middleware is designed to act as the bridge between the existing functional systems. This middleware translates the data between the different systems and keeps the same data across multiple systems in sync, keeps them consistent. Let's take a look at what this might look like. EAI systems keep our functional systems as they are and create a custom interface or middleware application for each existing functional system. This interface communicates with functional systems and translates its data as it's requested into a common format that the EAI server can understand. The EAI server ensures data integrity is maintained across the organization and provides a common single interface for management to easily access all data across the organization for reports and data analytics. From the manager's perspective, they're only dealing with a single system and database, when in reality, the data is being spread across the whole organization and only being pulled together at the last moment by the EAI server. The advantage of this kind of system is that you don't have to replace or make many changes to your existing functional systems. They remain intact, and you can keep using your existing business processes. The downside is that you still have to maintain each of these functional systems, which costs extra money and resources. You're also duplicating your efforts to some degree, as you have different databases, different software, and hardware for each business function. If you make any changes or upgrades to any of the underlying functional systems, you also have to rewrite your custom EAI interface, adding even more development costs. An alternative approach is Enterprise Resource Planning, or ERP for short. In this approach, all of the functional systems are completely replaced or redesigned to use one central database. And a set of standard procedures are used across the whole organization. As only one database is used, data integrity issues are eliminated, and we have no duplication of data or cases of having the same data in different formats. ERP systems are often purchased off the shelf, with few major customizations or changes, and they replace the existing functional systems that a business already has. Let's take a look at an example. In the ERP approach, a central server, database, and information system is set up which will contain all of the data for the organization in a single location. This ERP system is commonly purchased off the shelf from a vendor like SAP or Oracle and replaces all existing functional systems. Now, the ERP system provides support for each business function directly, and data integrity is maintained as everything is in a central database. Management can easily pull data from the ERP system for reports and data analytics. Big advantage of this kind of system is that integrating all of the business functions together allows us to make things more efficient, such as having smaller inventory as supplies are automatically ordered when needed, reducing lead time, that is, the time from when an order is made to when we can ship it out, and improved customer services and sales as we have all of the information about a customer in one place. This also gives management a greater real-time insights into an organization, as they don't have to go to each functional system and pull data. Instead, they can pull it right from the ERP server. One of the big downsides of this approach is that it's costly, as you are purchasing everything from a vendor and often require a recurring support contract. That means you're paying a big amount up front, as well as monthly payments. Replacing all of our functional systems with an off-the-shelf solution also means that all of our business processes and procedures must also change to match the new ERP system. And this means that there's going to be significant retraining costs for employees. Employees may also be resistant to new changes, and it could take significant effort to reorganize the business in a way that will work with the new ERP system. As I just mentioned, ERPs require significant change to an organization's business processes. Even when we're only looking at the processes themselves and not the technology or the IT behind them, these process redesign projects can be incredibly complex and expensive. There's a lot of detailed work that needs to be done to determine what changes to make, and it's really hard to estimate the value, if any, these process changes will add to our business. The redesign process can also be lengthy and require significant retraining of employees. Worst of all, you could make all of these changes and the outcome could be negative for your business. That means it could remove value instead of adding it. Or they might not actually accomplish your desired business goals. For these reasons, many businesses avoid creating their own tailor-made processes and instead adopt industry standard processes. So what are industry standard processes? Well, they're processes and procedures for performing common business functions that are used by multiple organizations across a whole industry. They detail how to use supporting ERP software, how to place orders, request quotes, communicate with suppliers, and much, much more. They essentially cover all functions and activities of a business. These standard processes often come built in or prepackaged with ERP software from vendors like SAP, Oracle, and Microsoft. So when you're buying an ERP system for your business, you not only get the ERP system itself, you also get a set of proven procedures for using the system and performing your business activities. To give an example of what these might look like, here's a process blueprint from SAP for completing an order. It might be a bit hard to see this in the video, but you can find a larger copy in your textbook on page 244. This essentially is a flowchart that explains the exact steps for making purchases and orders using SAP's ERP system. SAP provides thousands of these process blueprints with their software to document the procedures for completing each business function with their ERP system. So what are the advantages and disadvantages of using industry standard processes? Well, one big advantage is that we avoid the risk of undertaking our own costly business process redesign project that could lead to worse procedures or add no value at all. When you use industry standard processes, you know that they've been tried and tested in your industry and that they've been proven to add value. You also get them right away with the ERP software. You don't have to spend extra time developing them, and they are guaranteed to match your ERP system, as they came pre-built with it. Finally, you get support for using them and implementing these processes from the ERP vendor. Whereas if you were making a tailor-made solution yourself, you'd be on your own if something didn't quite go correctly. The main disadvantages for using these standardized procedures is that they may be very different from the ones you are currently using with your business. There'd be a significant retraining time required to teach each employee the new processes, and some employees may be resistant to this change. People often say they want change until it comes to being affected by the change themselves. These new processes also mean that they require substantial changes to the organization structure itself. So some organizational restructuring would be required, both in the departments and in terms of business activities. So both this retraining and reorganization require time and resources, and will incur some costs, especially if this means periods of downtime where you can't produce your product or even support it. Another disadvantage to consider is that using off-the-shelf software and processes may limit the competitive advantage you can gain from these systems. If everyone in the industry is using the same ERP system and the same processes and procedures, no one has any real competitive advantage in this area over their rivals. This ties into what we talked about earlier in the course, where competitive advantage through information technology alone is not really sustainable. Eventually, using a certain technology, such as ERP systems in this case, becomes so widespread in an industry that they no longer provide a competitive advantage and instead become mandatory. You'd be at a competitive disadvantage for not using ERPs and industry standard procedures. Recall again that complete competitive advantage can only be sustained once we add in the human element. That would be the people and employees of your business. In this case, the key would be training them to use the standard processes effectively and efficiently. One other thing to keep in mind is that these off-the-shelf solutions cost money, and normally this is not just a one-time payment, but a recurring cost for support and maintenance of the system. We're now going to move on and take a look at some specialized cross-functional systems that don't go quite as far as ERP systems in integrating everything. These systems aim to be cross-functional and departmental, but are targeted at specific business needs. First, we'll be investigating our Customer Relationship Management Systems, or CRMs for short. CRMs are systems that support the business processes of attracting, selling, managing, delivering, and supporting customers. They're a type of cross-functional system developed to overcome the problems functional systems and support all direct value chain activities involving customers. These systems are incredibly important as customers are the real lifeblood of your business. Without customers, you have no one buying your products. No one buying your products, that means you have no money coming in. And if you have no money coming in, that means you're not going to be in business for much longer. CRM software allows us to manage our relationship with existing customers and help keep them as customers. Recall from earlier lectures, we discussed that the cost of acquiring a new customer is significantly higher than maintaining your existing customer base. In fact, it's about 8 times more expensive to get a new customer than to sell to your existing ones. CRMs allow us to keep all of the information about a single customer in one place, making it easier to give them support and target marketing efforts to. In traditional functional systems, this data would be spread across the organization, and it would be unwieldy to collect on the demand. But CRMs are not just about sales and managing customers. CRMs also help with other parts of the customer lifecycle. So what is this customer lifecycle I just mentioned? Well, like all things in life and business, customer relationships with your company have a beginning and an end. Despite your best efforts, you'll eventually lose your existing customers, and this is why it's important to keep acquiring new ones. Otherwise, you'll have no customers left, no money coming in, and you'll be out of business. CRMs help in each phase of this life cycle, which starts with marketing. The goal of marketing is to attract new customers to your business. CRMs use data to help target your marketing at potential customers that are most likely to purchase your products. This can be done by using demographic information for your existing customers and targeting advertising and campaigns at potential customers with similar backgrounds. This is why it's critical that marketing has access to data about customers from other business functions. So the next phase in this life cycle is customer acquisition. This is when you finally make that sale to a prospective customer, and they place an order and become a real customer. CRMs, again, support this by allowing your salespersons to have access to customer data across the whole organization. For example, it might be helpful for sales to have access to marketing data to know what campaign attracted the customer. And it would be helpful for marketing to know what campaigns were successful in producing sales. After all, we want to know what we're doing is effective. If we're placing like print ads in a newspaper, we need to know if people are actually reading that and going to our business. A common way to do that is putting a coupon code or a referral code or a specific phone number to call that we can track back to that campaign. Allowing sales to have access to that is great because they know where the customer's coming from, and allowing marketing to know who actually purchase things based on those ads allows them to better targeting their advertising. Similarly, it's also important for sales to have access to things like current stock levels and inventory, and estimated lead times. If a customer calls up and needs 1,000 units of product right away, and you have none in stock, they're going to be rather disappointed if the sales promised they could get them right away, but in reality it would take weeks to manufacture more. Next up is relationship management. In this phase, the focus is on maintaining your customer base, offering product support, and gathering more sales from your existing customers. Again, in this phase, CRMs aid in this process by targeting sales efforts at customers that are most likely to purchase again. Since these are existing customers, it can greatly help the effort for sales to have access to customer support data. For example, if you have a customer who is constantly calling up support with issues they are having with a product they purchased from you, it might not be a great idea to do a sales call with them, trying to convince them to buy more of that same product that they're having issues with. Rather, sales could use this customer support data to target the call to the customer's needs and offer an alternative product or solutions that might work better for the customer, or maybe even a discount on an upgraded product that might solve their issues. The last phase is loss or churn. Inevitably, over time, your organization will lose customers. When this occurs, it's important to have an idea of the potential value of these customers that you're losing. CRM systems can help us gain insight into this and let you know who to target for retention and win-back efforts. For example, if a frequent customer stops making orders, you might want to know about this right away so you can start targeting them with win-back efforts and retention efforts. The idea would be to win them back as a customer. For example, sales might offer them reduced rates or better deals to try to retain their business. Again, this is why it's critical for CRM systems to cross functional boundaries. In this case, so sales and marketing can be alerted when a high-value customer stops placing orders, so retention efforts can be targeted towards them. The last thing I'll mention about CRMs is that they can be subdivided into three main components. Solicitation components are used to send messages and advertisements to a target market of potential customers. This messaging can be through emails, business websites, targeted ads, or through social media. You can also use more traditional methods such as sales calls, catalogs, and direct mail advertising. These all tie into the marketing activities of a business. Lead tracing components track sales leads and record information about contacts our sales team has had with potential customers. They help sales target their efforts at potential customers that are most likely to produce a sale in the future. Both solicitation and lead tracking tend to be pre-sale activities that happen before a customer has been acquired. The last component is relationship management. This component handles the post-sale activities, including customer support, retention, sales targeting existing customers, and win-back of lost high-value customers. The data from CRM systems aids with targeting these efforts at customers that are most likely to purchase more. It also helps understanding a customer's needs based on their support history and aiming efforts at winning back high-value customers that have been lost. There's one last type of cross-functional systems we will discuss today, and that is supply chain management systems, or SCM for short. Supply chain management systems are intra-organizational systems that enable companies to effectively handle the flow of goods from suppliers to customers. Recall from earlier in the lecture that intra-organizational systems are cross-functional systems that also cross organizational boundaries. Supply chains in this case are networks of organizations and facilities that transform raw materials into products delivered eventually to customers. They involve customers, retailers, distributors, manufacturers, suppliers, transportation companies, warehouses, inventories, and any other actors involved in the process of transforming raw materials into a product. SCM systems tie all of these different actors together and allow for inter-organizational communication between them. This enables more efficient processes and for the automation of things like ordering raw materials when inventories are low, or ensuring a manufacturing process finishes just in time for a product to be shipped out and delivered to another organization in the network that needs it just in time. Let's take a look at an example. Here we have the supply chain for REI, an online retailer of recreational equipment. In this case, we're looking specifically just at skiing products. Let's imagine you're purchasing some skis, bindings, boots, and poles from REI for an upcoming ski trip. These were all likely already in REI's inventory, as they showed in stock on their website, which allowed you to purchase them. So this is already an important feature of an SCM system. The inventory data and sales website are linked together, so stock levels shown to potential customers are updated in real time. Once you place an order, the items are removed from inventory and the sales website is updated. This is an important cross-functional feature, as allowing customers to buy products we don't have in stock could lead to issues. These days, customers expect products delivered in a timely fashion, and we don't want them to wait weeks for their online purchase if we don't have it in stock. The goods you purchased are in turn purchased from distributors. REI is simply a retailer and does not create their own products. In this example, the skis, bindings, and poles were purchased from distributor 1, and the boots from distributor 2. Distributors in turn purchase the equipment from manufacturers, who in turn purchase raw materials from suppliers. In this whole chain, the only real injection of cash is from you, the customer. You spent your money on the ski equipment. REI makes some margin on that sale and purchases the equipment from distributors, who in turn make some margin on that sale and purchase the equipment from manufacturers. Similarly, the manufacturers make some margin on their product and purchase raw materials from suppliers. At each step in the chain, more value is added to the product, but also more overhead and margin costs. Each of these organizations in this chain have their own inventory and need to closely monitor incoming and outgoing products and materials to ensure they don't run out of inventory. Having too much inventory is also a concern, as you have a finite amount of space to store it in, and there are costs associated with its storage. This is where SCM systems really provide a benefit to all organizations in the chain. As SCMs are interorganizational, they share limited inventory and order data between each entity in the chain, which allows for reduced inventory costs and sizes. As soon as you make your purchase from REI, they can inform their distributors that the inventory is getting low and have new stock arrive just in time to not go out of stock on their website. But also, not so soon that the equipment would take up too much space or sit unsold for too long. That could add costs, like renting more warehouse space to store it. The distributors and manufacturers in this chain also similarly use an SCM to order supplies on demand as they're needed. And this is why it's so important to correctly manage your relationship with suppliers, as any breakdown in this chain will leave you without any product to sell. And no product to sell means no money coming in. It also means some very disappointed customers. And this brings us to Supplier Relationship Management, or SRM. These are the business processes for managing all contacts between an organization and its suppliers. In this case, by suppliers, we mean any organization that sells us something. This idea is very similar to customer relationship management systems. But instead of dealing with customers, SRMs deals with suppliers, and they support business activities that involve a supplier. These are namely inbound logistics and procurement. The goal of SRM systems are to support the processes of sourcing materials and goods, purchasing them, and settling accounts. Let's look at each of these a little bit closer. So in the sourcing process, an SRM aids in finding vendors, assessing their capabilities, and then negotiating terms and conditions and formalizing them into a contract once a supplier is chosen. SRM systems may connect to a database of suppliers' products to aid with finding a desired good. For example, electronic component supplier companies like Mouser or DigiKey publicly provide databases of their products, which include things like a detailed description of each component, search and filtering tools to find components by the exact specifications you have, prices and information about bulk ordering discounts, and even detailed data sheets about each component. What we're seeing scroll by on the screen right now is an example of DigiKey's listing for transistors. Once a company has identified a vendor for their desired goods, they can move on to the purchasing phase. The purchasing activity of SRMs can help automate requests for information, questions, and create purchase orders. They provide an easy and standardized workflow for purchasing. In some cases, this is a manual process initiated by an employee. In others, it may be an automated process triggered by low inventory. The last major SMR activity is settlement. This process involves the warehouse or inventory receiving the ordered goods and then the accounting department paying the supplier. Again, we see the business procedures need to be cross-departmental. As in this case, inbound logistic activities like the warehouse receiving goods need to be closely tied with supporting activities like accounting and finance. So in this case, they can tell them to make the payment to the supplier after we receive the goods. If there's a breakdown in communication that didn't happen, it'd be pretty bad because we'd likely lose the supplier. Just like with customers, there's a cost associated with acquiring suppliers. And finding a good supplier is a good resource for your business. You don't want to lose them out of something silly like forgetting to pay them. Before we're done with this video, I should summarize a few key points. Supply chain management, or SCM, covers the long to short term and mostly involves big picture planning of business processes related to the supply chain and the flow of goods. Supply relationship management, or SRM, is more short-term focused and aimed at managing all contact with suppliers, including sourcing goods, purchasing them, and settlement. The goal of SRM systems is to improve efficiency of ordering and inventory management, as well as maintaining a positive relationship with suppliers. There are a number of benefits of these information systems on supply chain logistics. Interorganizational SCM and SRM systems reduce the costs of buying and selling, as you can quickly assess multiple vendors and the quality of their goods to find the lowest prices of goods that meet your business's requirements. Automating parts of the ordering and settlement process increase the speed of the supply chain and allow for smaller inventories as things arrive just in time as you need them. This saves money as you have less inventory just sitting on the shelf doing nothing, and improves relations with potential customers as all of your products are normally in stock. The key takeaway from this chapter are that functional silos are problematic, and your business will likely need at least a mix of functional and cross-functional systems, if not a full ERP system, to stay competitive. As these systems are becoming more commonplace, it's no longer a question of what competitive advantages will these cross-functional and inter-organizational systems bring, but rather in what ways you'll be at a disadvantage if you're not using them, as your business rivals surely will be. And with that thought, we reach the end of our Chapter 7 lecture video. If you've not already, I would highly recommend trying out the MyLab homework for this week, as it may help clear up any remaining questions you may have. As always, thank you for watching, and have a great day.